The Geoscience Community Analysis Toolkit, Geocat, is a product of the National Center for Atmospheric Research's Computational and Information Systems Lab. Support for Geocat is provided by the United States National Science Foundation. The overall Geocat effort is for the development of computational analysis and visualization functionalities for geosciences data in the modern Python ecosystem. The Geocat effort also provides documentation, examples, training, and support. The data analysis and plotting needs of the geoscience community have been addressed for decades with the NCAR command language, or NCL. NCAR's decision to pivot to Python as the language of choice came in tandem with a requirement that the tools found in NCL be moved to a more open development model. Today, the Geocat team is addressing the needs for open development Python data analysis and plotting tools by developing Geocat toolkits and several related GitHub repositories. Geocat Comp refers to both the whole computational component of the Geocat project and a single GitHub repository. The Geocat Comp repository is an interpreted language repository that serves as a user API to access the entire computational toolkit from the developer standpoint. The computational functions implemented in the Geocat toolkit are implemented in either pure Python in Geocat Comp or in Fortran through NumPy's F2Py packager in Geocat F2Py. All computational functions from both toolkits are available in the Geocat Comp namespace after installation. Stable releases of the Geocat Comp package can be found on NCAR's Anaconda channel. One of the essential goals of the Geocat team with Geocat Comp implementation is scalability. Dask parallelization is leveraged wherever it is needed to provide parallelism everywhere, from personal laptops to cloud platforms. Moreover, the entirety of Geocat Comp functionality is Xarray and NumPy compatible. The Geocat team has created and is continuously expanding an example plotting gallery for transitioning the visualization functionalities of NCL and Pingle into the Python ecosystem. Geocat Examples uses Matplotlib and Cartopy for its essential plotting and projection tasks in conjunction with an additional Geocat utility package named Geocat Viz for the examples where higher-level implementation is of interest. The Geocat Examples library currently houses over 100 Python scripts, all of which replicate and are linked to the original NCL examples gallery. This allows NCL users to easily locate an NCL example of interest in the Geocat Examples library. Navigating directly to the Geocat Examples gallery displays a list of links to specific styles of plots. Using the gallery link from the homepage, we'll navigate to an expanded and more visually intuitive list of available examples. Below the Gallery tab is the Installation tab. This tab walks new users through the process of creating a Conda environment that is conducive to running the Geocat example code locally. In order to provide training materials in the future, the Geocat team is working with the recently started NSF-funded Project Pythia Infrastructure Working Group. Project Pythia is a community resource for learning how to analyze geoscience data using the scientific Python ecosystem. The Geocat team will soon deploy several Jupyter notebooks that demonstrate parallelized execution of a number of computational functions in AWS as part of an NCAR internal collaboration project, Science at Scale. One of the most significant research focuses of the Geocat group in the near future will be the pre-processing and visualization of unstructured grids such as CAMSE and MPAS. The Geocat team has already begun collaborating and seeking further collaborations with outside developers on investigating unstructured grids. In addition to maintaining active development projects, the Geocat team provides continuous support for NCL and other Python modules built on NCL like Wharf Python, Pingle, and PyNeo, while also providing support for other NCAR software and research.